let's discuss a Fortify finding. Fortify is a static code analyzer. There are other tools, some of which I've used, including Clockworks, but this is a finding from Fortify, so I've run it through the testing and I know it works. I know the problem, I know what works right now. So, basically, this is C++ code. There's a Fortify finding of a buffer overflow while using a get host name. And so, the things we'd need to look at would be obviously the code and obviously the definition of get host name. Now, get host name basically is a POSIX function, and this is a POSIX compliant machine that it not only POSIX compliant, POSIX certified. AIX is POSIX certified. So in that case, we'd like to know what we did wrong with get host name that caused this finding. Okay, so, and by we, whoever the coder was, you know how that is. Anyway, basically there was a buffer, 17-byte buffer, a memset, a get host name, no error was checked. We didn't allow an extra byte for a null termination character, and then we proceeded as if everything was hunky-dory and used it. And so in this example, I'm printing it, and that would be an example of that situation, of that problem. Okay, so let's look at the definition of get host name and see what it is that's expected, what was defined, what we did. It's POSIX, so this is the opengroup.org. It's POSIX on a POSIX certified machine we're talking about here, AIX. Well, yeah, it could also be another machine, but this is the one that it showed up on. So there's our function, gethostname, unistd.h. That's the POSIX header. Here's our function. It returns an int. It takes a name as a character pointer and a length. And so, right away, we can see a couple of things which, won't make a lot of sense when I tell you that for POSIX, there is no defined error. But anyway, Fortify being fortified doesn't really care about that. They're looking at the fact that there is an error code returned of -1 if there's an error, and we didn't check it. Yep, there it is. -1 shall be returned upon successful completion. There's a 0. There's a variable. Okay, so name length. There is a name length, so this is probably our buffer on the stack or wherever. But this host name max is not a define like you think it is. It's actually coming from the sys config. And so we could query it and see what the max is. On this Linux box, it would be 64. There's the function. I can show you a call a little bit later, but instead of hostname max, you'll actually call that function with _sc, there it is. There's a definition, there's the parameter you use to get the max. You'll wind up with 64 on this box, all is well and good. But, going back to Fortify's complaint, we didn't check our error. We did not. So, well, going back to the error code, the error example. So, there's the code. The buffer was a bit small. I can talk about that in a minute. We didn't check the error code, even though there really is none. And we proceeded as if there was no problem. And we didn't leave room for another null. So Fortify doesn't just look at our instance. In fact, it'll never look at our instance and say, oh, he's working on a POSIX certified machine. It'll actually try to make this generic across all the machines for that function and make us follow rules which will allow us to actually move the code from one to another. And in doing that, we've made a couple of errors. We didn't check the return code. We didn't make that big enough. And let's see an example of where we've actually resolved those as far as Fortify is concerned. Okay, so we have a static here of ch hostname. We've increased the buffer to 32, which is an old maximum, but at least it was an existing maximum. And we're only going to get our hostname once. And in our function, which is Fortify underscore get hostname, let's say, we're going to return a constant char pointer. So we're not going to allow our code to modify what's coming back. We're not going to make it easy for them. We're going to tell them not to with that constant char pointer. So here when we get it, we are checking the return code now, which for us can never fail. But if it does, if there's some new rule that makes it fail, we'll do the memset, set it all to 0, all will be good. We even left an extra byte for our null termination. So we are always null terminated now. Whereas before you could argue that we were not. As you can see here, unspecified whether the return name is null terminated under the condition that there's insufficient length. Yeah. Okay, so then that's the Fortify complaint, the Fortify remediation. Here's a different product, Confluence, which has a rule, detect and handle POSIX library errors, or, you have a finding, and that's basically what it's telling us. We have a finding. And so we've violated a couple of rules for a couple of different products. If we were on Linux, there could be different error codes. If Linux were not POSIX certified, but POSIX compliant, doesn't matter. They've defined new codes. There are other conditions out there. Let's get back, and there's certainly a solution. Now, as we go forward, Fortify could still complain and say, hey, 32, that's not enough. 64 is a maximum on Linux. Why don't you make it 64? And then they could even ask us to check the limit. And then we would do that via function. But, all that's relatively nonsense because there is a maximum limit to that name. It's actually 40 if you're doing email. You can't really send more than that through email. Or it's 64 in Linux, and the different things you do might have a different limit, but the lowest limit I've seen is 19. So our 17 limit was just too low. 32 is more than enough. Come on, it's the host name. It's about 12 bytes here. If you wanted to get the limit, that's actually the sysconfig call. And then you'd actually check the return value from that. If that failed, you check error no. I mean, this is getting into absurd. It's nonsense. If that call failed, I don't know what you do. if they both failed, if the length returned -1, but there is no error node, that means it's unlimited. That is a condition that doesn't exist. There is no unlimited host name. You cannot use all of memory to hold your host name. It's not practical. So Fortify should never go down that route. And then, but if you were to make it that way, you could go down that way. And then, of course, you'd have to free your memory before you exit and allocate your temp. Here's an example of where I did something like that. I just used the max limit there of 256, which is a grossest highest limit, and it's a reasonable number, so no problem. And then from there, I'm getting the host name, I'm checking the error, I'm string duping, I'm returning that. Now, what we've done is we probably traded one finding for another, because you're going to have to free this eventually. So you're going to have to keep track of that pointer, which will only be allocated once. So call it from main and then free it before you exit. But even that's sort of unnecessary, but it would never have to be touched per current definitions. Okay, but I still like this solution for the simplicity. Right there. You want to make it 64, make it 64. Knock yourself out. All right, thank you very much. Have a good day.